Welcome. In this video, we will discuss about general terms used in periodic table. So there are few important terms which we need to know in order to understand the periodic table properly. So first term which we are going to see is normal element or representative element. Representative element. So S and P block elements except inert gases. So normal S and P block elements except noble gases are called representative elements, and they actually represent the most of the elements present in nature. That means the compounds available in nature are mainly made up of these elements. That's the reason they are called representative element. Then there is typical elements. Typical elements are elements which show properties of respective group. So generally third period elements are called typical elements because they sum up the properties of each group. So except noble gas, sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. These are called actually typical elements because they sum up the properties of respective group to which they belong to. We could have considered second period elements as typical elements, but we don't because they have high electronegativity and small size, and they show most often exceptional properties or anomalous behavior. So they cannot be typical elements. So third term which we are going to learn is bridge element. Bridge elements. So bridge elements are the elements which actually connect or which act as a bridge in their properties to two different groups. Like for example, magnesium bridges between sodium and copper. So this is also a bridge element. Similarly, calcium bridges potassium and silver with respect to some properties only. That's why they are called bridge elements. Then we say fourth term, diagonal relationship. Diagonal relationship. Diagonal relationship is between elements of second period and third period. That second period element show relationship with third period element which are present diagonally. So best example is actually lithium and magnesium. They are present diagonally in periodic table. From the lithium belongs to second period and magnesium belongs to third period, and they are located diagonally. So they show similarity in properties. Similarly, beryllium and aluminium, and we have boron and silicon. And later stages also this diagonal relationship is seen, but the properties do not vary to more extent, so we don't consider them, we neglect them. So that's the diagonal relationship and the element showing diagonal relationship. The next term which we use is actually transition element. Transition element. Strictly speaking, transition elements are elements with at least one unpaired d electron in ground state or excited state. So they are generally the elements present in group 3 to group 12, and the best example is actually iron, cobalt, etc. There are few elements like zinc, cadmium and mercury which do not follow this rule. Actually, they don't have partially filled d orbital or d subshell in ground state or in excited state, still they are kept in D block for the sake of convenience. The last term which you are going to see, this was fifth term. This is the sixth term, is actually inner transition elements. So inner transition elements. So inner transition elements are F block elements. They are similar to D block elements in most of the properties, but they are separately kept in periodic table for the sake of understanding the horizontal similarity which they show. So that's the inner transition element. Then we see how to name an element if it has atomic number greater than 100. The elements up to 100 atomic number are already named. So IUPAC naming of elements with Z greater than 100. So this is the next topic which we are going to discuss. So they are actually named by three letter symbols, based on first letter of numbers from 0 to 9, that is 0 to 9. We know that different numbers are called in different names. So let us list that. So these are actually named in Greek letters. So in Greek letter 0 is actually nil, 1 is un, 2 is bi, 3 is tri, then we have 4 quad, 5 pent, 6 hex, 7 sept, 8 is oct, and 9 is n. So using these letters we are going to name the elements. So we should know, while writing name, the Greek letters of their atomic number is written together with suffix IUM at the end. So first example let me give. Say Z equal to 101 is the atomic number of an element. Then in Greek letters, one is nil. First letter is always kept capital. So in Greek letters, one is actually un. So un, first letter is kept capital always. Then nil. So un nil. Then again one is there, so that is un. So now we have addressed all the digits of the atomic number. Now to this we add IUM as suffix and write. So un nil unium is actually the element with atomic number 101. Similarly, if Z is equal to 109, then it is un, nil, n, ium. So these are the names actually. When it comes to symbols, we write only the first letter of the name. So u, n, u. So that means un, nil, unium. That means it is 101. This is the symbol of the element with atomic number 101. Similarly, here 109, u, n, e. Like this we can have z equal to 118, un, oct, ium. So octium. So the symbol will be u, o. So like this actually we can name any element with atomic number, respective atomic number, using these digits. Now till how long this name will be in practice is till the scientists, that is IUPAC, does not come to conclusion about the permanent name according to the time, place, and the people invented, etc. Till then, a newly invented element will always be given this name. So that's about IUPAC naming of the elements. Thank you.